So welcome back to the second part of machine learning models in clouds. So machine learning in clouds, what does that mean? The first part really gave you a very moderate introduction, let's say, into machine learning. We started with a very simple idea of a classification of flowers. And over the time, we have seen the perceptron learning model is one part of it. So perceptron derived from the human mind, so to speak, how we learn as humans. Of course, a little bit more in an abstract notation, learning weights instead of connections between neurons really. But essentially it is very similar like we humans do learning. Of course, in subsequent lectures, particularly lecture 6 and 7, you will see how to connect those neurons to make really an interesting learning machine. Which then is called artificial neural networks. And then if you do that in enormous type of layers, you would have even deep learning, but usually those layers are of course very smart. So it's not just neurons connected, it's also different type of layers which do different things. So very interesting still that all of this is coming out from a, let's say, perceptron learning models in the 50s, which laid the foundation for machine learning. And you have seen, essentially, we have started with a function that was unclear. So some people also relate to it as function approximation, which is in statistics and in other areas sometimes established. So it's very similar, but also what's basically we have in machine learning is, and what we add in further models is that we want to predict the future, right? So not only statistics of the data we have, we want to learn from the data for the future. And you will see in subsequent lectures that this is a little bit a different thing. So we want to prepare the machine learning models for get future points right. But let us come back to machine learning as we have here. Machine learning on a very pragmatic lecture. I told you this is one of the more practical emphasized lectures. So we want to really pick one concrete solution here. And if you now take the solution, this stepwise approach, and you take it to, let's say, Amazon, you take it to the Google Cloud, you will find the steps are very much similar. That's why I'm teaching it, right? So of course, you would have not a Spark cluster and HDinsight. That's very specific for Microsoft Azure. But for instance, Amazon has Elastic MapReduce Cloud we will talk about, which is similar. So, and there are other services which are similar. But you will find usually this kind of 7 steps that you have here is a guiding light for you to always go through the different clouds, vendors, and offers, and to check and work on a problem. As I said, again, it varies. For instance, some maybe don't have even a Jupyter notebook, which is sad. So you have to go with SSH into it and work on the problem perhaps yourself. But we see a tendency that, for instance, Jupyter is coming along mostly everywhere. The question is still if they have Apache Spark underneath, there might be something different underneath, but also there might be a framework, something to compute in the cloud, like Apache Hadoop, maybe with Elastic MapReduce, for example, that would then help you to solve a problem. Now, when we think about the problem, we thought about the food aspect that we had in the previous part of the lecture, where we stimulated a little bit that the linear learning model would be perhaps a little bit, less suitable for this. Linear in the terms of the simple perceptron model. So here we have something a bit more interesting to learn, and we assume that somehow the patterns that we see in the food inspections by these violations, there's probably some non-linearity in it. It's probably not so straightforward just to analyze it. And now we will go basically very specifically through the 7 steps here, and we'll use this application to show you really idea how that could work when you work with cloud computing and machine learning. So the first step is usually always think about your credits, think about your subscription. It sounds very trivial. It sounds a little bit, okay, of course I have to pay for it. But of course, take away the message that from practical experience, this is loaded. And although here the GUI is, changed here and there, it depends, are you in the US? Do you get $100 credit? Do you get Euro credits? If you have a free trial as a student, of course, then you're kind of thinking, yeah, it doesn't matter, right? So I don't pay anyway. Once you come to a company, this light is completely changing. So you would see like you're just one employer of maybe 4,000 and maybe 50% want to use a cloud. If all of them use now the cloud, the free trial will not work long. So you see the spending of this will be of course cost something. And we will have subsequent lectures analyzing this a little bit more, what it means with having cost of ownership versus pay by use, right? Which are the kind of different models you have there. Of course, a company saves a lot of money by not having their own computing center, right? And all of this money is kind of saved, but doesn't mean they can now hire 1,000 more people. They have to put that somewhere on the bank so that the people can still compute in the cloud. So basically, this is an important aspect of it. And you see here as an example, very, let's say, simple example that you have here two aspects. One is of it is storage. One is of it is a Spark cluster, where already a little bit of 50 cents have been, of course, spent here. So this is, of course, all kind of in the moment thing. So basically, in the background, your machine's already running. You have usually a cost which is very well defined. So you would say that Amazon, you would say that MS Azure, they all show you exactly how much you have to pay usually for an hour in this or that service. But of course, while you looking at this cost estimation, you will always see, okay, there may be some differences there. What you also will notice is that essentially if you go now and log out of this, you're logged in, you see your subscription, and there's one point I can't say enough. And this is of course here not only because of you and your assignments, because we have limited free trial credits. It's also if you go to the company, because this could be real big trouble. I told that before, and I will tell it, I think 3 times more during this course and also in subsequent courses. Always when you log out, that doesn't mean that you don't use the services anymore, right? It's different. It's basically not like Facebook is operating in the back for you. Here we have the cloud is operating in the back for you. It will compute further. It will have the services there ready for use. And this is, of course, something if you don't use them, basically Amazon and others, MS Azure and so on, they don't care if you don't use it. They are provisioned, so they're ready to use, right? And this is, of course, an aspect which you should not overlook. While you log out or basically you go to vacation for 3-4 weeks, nobody's using the system, you have to pay for 4 weeks. Right. So of course there are emergencies. You can basically say sometimes and talk with grace periods about Amazon and others, but usually you have to see that quickly the cost can be exploding, and it would be of course okay and justified in a company if this is really used by something. If you have, let's say, a better machine learning model that predicts better your business, and then have, let's say, 5,000 more users in the next month. So there's a return of investment, so to speak. But let's say if this is idle, just running around, it's a very sad thing. So essentially, this is very important. My recommendation in the course is that's why basically delete the clustered cloud resources immediately when you have done your assignment, or if you say are you going to go a week somewhere to Eyjafjallajökull or somewhere in the nature, Vik and Jökulsárlón, whatever, please delete the cluster cloud resources and create them again. It's very quick to create them once you come back. Right, and I don't care if the screenshot then says there's a different type of, I mean, it's the same type of computing resource, but you will see that some of the identities will be not the same. I don't care about these things. So more important is that I see that, your login here on the top is visible. That's important, but also that the whole idea of the assignment, this walkthrough, is of course performed. But I think this is a very smart way of saying and just getting a kind of modus operandi for it, that once you want to log out here in the assignments, think about that you better delete the cloud resources. Right, so how we start with this? We said somehow we need, once we have a subscription, we want to have services in the cloud. And of course, then there are different options. You will see that Amazon has maybe 150 options services, and in this area. And you would say, if you take the whole service portfolio, it's even more. But how do you now combine, and what to know to combine? This is, of course, something where you usually now have to go through all the service portfolio. And the reasoning here in the course of learning, Spark with the PySpark kernel and things like that is that this is everywhere already these days in cloud. So you can really use this for machine learning at scale, at least to a significant degree. And you see that here in this step. Usually you will find some deployment script already existing. Here you see there's some JSON scripts that are already existing. What you can basically use in order to tell the cloud what services should be created. And you see here is the Azure Quick Start for Spark. You get a couple of Spark clusters, which have a certain number of nodes. Also, these nodes, head nodes, worker nodes, doesn't mean anything to you. We will see how that materializes in the next lecture. But take away the message that we have to tell the cloud now what you want, right? It's a little bit like in the shop. You have to pick from all the services. Now, having just compute in terms of Spark, in terms of using machine learning would be not enough. We need data. So automatically it comes to the point that if there's computing, then we need some storage. This is usually a more or less equation that you can see. Of course, you can always download the data somewhere else, but in the machine learning model needs to be, somewhere data has been maybe dropped there somewhere. So usually would have also some storage. And these scripts tell that, but in a semi-automatic deployable fashion. So in often cases these days, you have that clouds can be automatically deployed in terms of technologies, also to save, let's say, lots of manual work. And this is, of course, something also how you can scale. So you would add here just a couple of more nodes or just a couple of more worker nodes, and suddenly your, let's say, machine learning algorithm will scale much better to the number of big data items you have in your data set. So this is something which also enables a scaling already, that you have a deployment, that you don't install, let's say, Spark yourself, you download it, it's an open source project, you can do this, you log into every single node and install it there and then connect it with IP addresses, etc., etc., etc. So you would have a long, long way actually to make that work. So instead you have this Azure Resource Manager templates, which are just actually there for this. They take care of this deployment of Spark. So that means Spark will be on any node. Of course, you see that a little bit illustrated with this red one. How many nodes you need depends, of course, on the application domain problem. You don't need lots of worker nodes if you have very small data. Then you basically underutilize. On the same point, if you have lots of petabytes, don't just use 2 worker nodes or something. Then you need much more worker nodes. Of course, the amount now will cost, right? So this is exactly now where clouds make money with. So the storage, how many, terabytes you want to store there, or maybe even petabytes, but also, of course, how much scalable should be computing be? And you see that, of course, a Spark cluster costs something depending on the amount of hardware you put in. We will talk about this details about Apache Spark. It's in the moment a more black box. We'll talk about this in the subsequent lecture, lecture 3, which is kind of associated with this one, also relevant for your assignment, but more to a degree that you then understand how really the optimization in the machine learning works using Apache Spark underneath, the distribution of data, the distributed computing aspect of it. So for the sake of learning how it works here in the cloud, you see in a way, you get away with not learning about Spark, really. You can just say, okay, let's have Spark there, and it will be running. And how exactly this all works, we maybe don't know, because we can nicely focus on Python. Before we do this, we have the script that we execute, and then you see here a couple of questions, really, that is all around essentially security aspects. So if you want to log into your cluster to start it, you every now and then ask for a password. Here is a warning again: if you do this, make sure you have very strong passwords with special characters and so on, not test 1, 2, 3, because usually these systems already check now. Before they get deployed, people would double check and would say essentially, okay, this is something where there's a weak password, we don't even deploy it. And you see there are different other aspects. You can name the aspects, like here. I would suggest a good naming also for you as a learning experience when you come to a company and everything is called test cluster. you immediately found maybe with your colleagues like 20 or 30 test cluster, and you have a hard time to directly find yours or the one that are relevant for your application or for your domain, depending on, of course, the branches or sectors in your industry. So in this sense, pick wise passwords, actually also name the aspects as best as possible. Of course, not maybe in a 30, 40, 50, 60 characters way. Of course, keep it a little bit maybe shortcutted, but still think about that this is, of course, one way of easily operate the cloud. You will find things quicker. You see also here the subscription model is linked to it. You could have different subscriptions in the company. That's actually often in divisions or basically on branches. This is an important aspect here for us. It's just Azure for students. The region sometimes matters. If you think you have here an East Coast US, this depends on how many data centers are around in these cloud offerings. In Amazon, it's the same way as in MS Azure. As you see here, for instance, you can pick where are you. The reason why I picked here East US is that I found it is much more responsive than others that I tried. Let's, for instance, in Europe, even if we are in Europe here, basically then East US was always more responsive, and this could be also basically related to the means of how many people are there really that already use the clouds, how much capacity is there in the data centers there, and so forth. So once you go to the step 2, you basically have these aspects identified. You say review and create. Then you will see after some time when you wait, as I also was describing in the assignment and so on, you will see that actually 2 aspects will be created out of this template. And this is really, you know, how you can also make it bigger. If you want to create another template, you basically can, you know, change the number of aspects that are related to this template. But of course, here for the sake of the course, that's enough. Also, of course, the storage that is there just created is a typical storage account, and you see on the right-hand side that this could be different ones. So there's different services for blobs. You have the data lake. You have also typical SSDs, essentially as managed disks or files, and all of them have different pricing models, which also give you the awareness. Now that's where it starts, right? When you would have SSDs, you see it's actually then, you know, having different pricing models than just using the data lake. However, some of them could be then more responsive, some of them could be more secure, and depending on really on the application you have, you need one or the other. And this is true for all the services you have basically in your portfolio. You will see different pricing model usually for all the services. This is just an example out of the, let's say, relatively trivial storage area where you can have already different services to fill your storage. You also see the created HDinsight cluster, which is now a Spark cluster running on the cloud in Microsoft somewhere and somewhere in the East US. We don't know exactly where. You can probably look that up, but also here and there, these data centers are top secret and not revealed all for security reasons. So that's why it's interesting to see that you have this kind of created and can now look at more aspects to it. Now, when we go into this, you click on it, you see more details, basically what's there. So you see it's running, which is very good. So here you see also failures if it's not anymore running, obviously. You can go to documentation, which is quite nice. And this is all nice integrated. If you now look back 10 years ago to create such a cluster, it wasn't like that, right? So this was really tough to have SSH keys pulled around. The technology was just evolving. You know, there was Apache Hadoop starting in different versions. So this is becoming these days in cloud computing really so attractive, stable. That is really a very good idea for companies to think about this at least before, you know, potting off and creating their own Spark clusters. Of course, creating your own Spark cluster has a benefit of being completely secure. It's in your house. But even there, you could be hacked from the internet, especially in these days in COVID times where everybody needs more or less a remote access, working from home. You basically then have, of course, these challenges. But essentially, of course, this means you have to trust now MS Azure to have a Spark cluster, which is secure because you will upload your data to it, right? In our cases here in the example, we will just simply download it because it's already part of a tutorial here. But of course, usually you also have to trust now this with your data in order to get your Apache Spark job, or basically your analysis then running. You see also here on the bottom left a little bit the cluster size, and this shows you already there are different types in an Apache Spark cluster called head and worker. They're doing different jobs related to the analysis of the data, and this is something what we will look up in lecture 3, so don't worry about this. You see also the size, which usually reflects what type it is, how big it is, also which type of CPUs and so on. This is all, of course, relevant. And also not only relevant for performance, it's relevant for the costs. For a cutting-edge GPU, for instance, a V100, you pay much more than an old Pascal machine. Basically, this is, of course, probably very clear, but also means this is costs which you as a company or a startup have really to think about it. However, as I said, it's really nice to work with in this particular example because we have not only Spark, which is a distributed computing open source framework, we also can use directly Jupyter with it and Python. And this is an integration that is for machine learning just perfect. Lots of packages are in Python. These days, traditionally, it was more R. These days, it's moving significantly actually towards Python everywhere. And with this, you basically have a very nice opportunity just clicking here on this cluster dashboards, and there's certain others like, Ambari, which is more related to deployment. There's Yarn, which is yet another resource negotiator, basically then also coming as a resource manager. It's not interesting for us right now. We just use a Jupyter notebook like you do in your assignments. But this is all one click. And this is essentially amazing if you think about it. So this is now establishing, the connections between all the hardware in the cloud. It has all the software now. You have Apache Spark software nicely already deployed, scalable. You can always remove or add different worker nodes, so you can scale up, scale down. Very nice. You have not only Spark essentially, we have also Jupyter accessing it. So there's Python already installed for you in the right version. There's Jupyter to have a really nice, let's say, GUI or dashboard working with it. So we will also see then in lecture 3 other aspects of Spark, so the machine learning library, how that helps, or SQL. We had touched this a little bit here already when we integrate this with so-called PySpark kernels, but lecture 3 will discuss a little bit about it. Now, this is interesting to think about when you now look at this. We start essentially by thinking about what we really need for our machine learning problem. We basically said like logistic regression would be quite interesting, so that's what we want to have. We want to have a pipeline. This is something which just, is a way how we use Spark with different aspects of working. So you have a pipeline. Also, this is not obvious, but will come in lecture 3 again as an explanation. And then we add in these pipelines several aspects of the work. And as I said to you, the classification like logistic regression is not the only thing. We have to work on the data, on the features. So you see in PySpark ML feature, we have several helper, let's say, tools really to make our problem more suitable for machine learning. You have seen machine learning is usually very math oriented. We have a mathematical model that is learned in some way or another. Matrix multiplications, basically in deep learning, but here we have seen, let's say, linear combinations. But this is really depending, of course, on your classification algorithm and so on. Here we import the hashing and actually the tokenizer to think about a little bit that we have to transform later the text, right? The violations. If you remember the application setup, we have text violations. So how do you want to multiply text with, and weights? So to learn the weights. So it's somehow not really possible. So essentially we need some mechanism in this feature set that you got here from PySpark to transform the text representation of the data more to a sort of numerical one, or basically one that is really numbers, so that the machine learning algorithms can really learn something. And we'll see how that materializes in subsequent steps. But of course, as you know, it's a good way. You don't necessarily have to do it, but I would always recommend it to always do the imports at the top, right? It's a bit, let's say, more kind of modus operandi to get your code clean. For SQL, it's a structured query language in the past. Of course, with document stores and key value stores, this gets also less used these days. It's a back and forth, really. But here you have a certain way how to do data, right? And you could say in future, we do more pandas in all of these things, maybe other databases. Here we have this kind of helper called SQL, where we do some functions out of it just to explain a little bit the data later that you will see and play around with the types. Now, a very interesting thing is once you have done all the imports and particularly the PySparks, then you will see that the Jupyter notebook will know you have a PySpark kernel, so it starts in Spark application if you execute the first cell. Now, also important is that once you do the Shift Enter, remember the star, right? If there's just a star in 1 here instead of the 1, then it means it's still working on it, right? And I've seen, let's say, from the Q&A sessions in the past that some people are really eager of execute, Shift Enter, Shift Enter, Shift Enter. But if there is a asterisk or this kind of star still, then that means it has been not completely executed or it's in execution. So we have to wait. And in this assignment, you will notice you have to wait until the Spark session is available, right? And it will show you a little bit of specific application ID, which of course will vary from, student to student. We see it's idle, it doesn't have anything to do. You can click the links a little bit and understand some things, but the interesting aspect for us is we have now a handle to the Spark, which is called essentially Spark. So we can do something on Apache Spark with Python, giving this PySpark. And this is a very nice thing again, so that we start now of using this handle on this real installation on the big cluster to work on it with machine learning. Now, when you do this session, the first thing to think about it, of course, is then what is a data, right? So machine learning starts from data, so we have to look at this. And this is, of course, nice because here you will see there's already a Windows Azure storage blob that has been put there as a kind of, let's say, tutorial example, if you want, which is our food inspection data. The interesting thing is, again, what I told you in the first part of the course, there are 2 files. You don't see that, but essentially it says like, there's a food inspections 1, which will be our training set, and there's a food inspection 2, which is our test set that we will use later. As we're training now our machine learning algorithm, we want to take, of course, a training set first. So you have here some other aspects of it, like infer the schema of it, which makes sense to do so because it's relatively straightforward. And the way how this data is stored, if you look into it, you can also use this and look at it in the data later. When we look in the inspections, then you see it's a comma separated value list, which is a usual, let's say, format for data in machine learning. It's not always like that, of course. In many occasions it is like this. Sometimes it's a corporate database, SQL database, you get things out. As I said, there could be document stores, key value stores these days, which is more the field of databases, or new databases really that are often used, which don't have a very strong schema like SQL. They're much more flexible in adding fields and removing and so on. Essentially, here you do the same, Shift Enter in the Python, and you will see the asterisk means it is loading data. And of course, now if you think about the size of the data more and more, this is an important aspect. So again, think about if you want to work on inspections and it's still a star, that means the processing is not done yet. So there is nothing in inspections loaded. So this is an important aspect, again, to think about it for different cells. Once we have this, a usual way how machine learning works is you have to work on features. It's rarely in my practice in the last 15 years the case that you just take a data set and just throw it to machine learning and then you're done. So essentially you would have a real long process of working on the features. You work on your data, even if it's images these days. You think about different features in the image. You think about different aspects in the data that help you. Now, if you see here the schema, print schema, and you see, oh my God, there are lots of fields, right? Lots of columns in this violations of food. And actually what we thought a pattern would be is that we look at the violations, of course, and then the result, which would be our label. So this is what we pick here in selecting the interesting columns. And selecting the interesting columns is really now thinking which of the attributes, similar like the flower, Iris setosa, Iris virginica, the type. So the third we did, not used, but this was more sampling. But if you remember what the similar aspect in the flowers was, we basically just took the petal, right? The length and the width, not the sepal. So there were kind of two attributes we left out, which means it's often the case that not all features in the data are necessary to create a classifier. And this is a very common aspect in machine learning. Feature selection, sometimes it's even feature generation, and so on, which is of course a big topic in machine learning in general, where you can, have interesting aspects, how to help the classifier really to understand your data and then of course better learn from your data. Here you see in the Python script, we essentially picked just 4, the ID, and of course the name of the restaurant is somewhat interesting for us, but we skip everything else, just saying the violations is interesting for us, and we know the results. So this is something which is already now the features and the aspects we look at. You see in the some renaming and of course then the dropping of this, so there's more an internal small thing. More interesting is that we have 13,000. And interesting is also that, underneath it puts the whole data frame in memory. So we are away from essentially the files. And the interesting aspect with it, as I told you, when working with Apache Spark, it was memory oriented. So it likes to be in memory all the time. So if you don't have enough memory, then, Spark versus Hadoop is not so dramatic anymore. If you have to store everything to disk. The key differentiator between, for instance, Apache Spark processing and Hadoop processing is often in the idea of, using much more memory. And of course, then also the pipelines, which are interesting, and RDDs, but all of this will be coming in lecture 3 then. And this essentially has now finished our feature selection mechanism. We will talk about this more in lecture 6 and 7 when we want to have neural networks with images and so on. You will see also there we need to do some feature selection and actually some data preparation for this you have already done in one of the practical lectures. 0.1 was already in the MNIST data, where we have, basically looked a little bit how to do work on it, how to look at it. And the next step then will be, of course, understanding it and perform feature selection. Once you have then done this, you want to explore the data, you want to look into it. So this is just essentially saying you take one sample and look at it. So the row ID and name of the restaurant is perhaps now for us not so interesting, but you get more an idea of this violation. So this is all text, surface is clean and dustless cleaning methods, etc. You see it's a kind of sentiment analysis already in our head happening that, okay, this might be good or bad if you look at these texts. And this is what we're gonna, derive in our classifier. Now, the interesting aspect is if you prepare the data, and you have to think about it that now we said it's a binary classification problem. We want to know it's pass or fail. And the question is this really 2 classes, right? So we need fail and pass here as a binary classification problem, but we need to look at the data. If you look at the top 5 rows, it sounds very obvious. So we have here the vector X, all the data samples, and all the features around it with violations and name, etc. And it gives you always a fail and pass. But wait a minute. If you look more, and that's why you need to investigate in the data, you don't need to have the data by heart known, but you have to look what's inside the data. Otherwise, you don't understand your classifier. Here you see a good example that suddenly there are 5 classes. Right? The results can not only be fail and pass, there's a variety in between, which means business not located, out of business, pass with conditions. So essentially you can count them, what you do there with small select statements, and see there's lots of pass and fails, but still some others that we maybe want to remove. And the number of those are not so significant, so we may be okay of removing it. If, of course, this number would be much more higher, then you would have maybe a kind of very problem in your machine learning data set, because you have either an unbalanced problem. And we see here it's already a little bit an unbalanced class problem, that there are much more passes than fails. But this is, of course, something which is often machine learning and needs to be a little bit careful looked at. As this is a very trivial problem here, it doesn't matter so much. But essentially what I'm saying is, think about rubbish in means rubbish out, and your classifier will expect like 2 classes, and these are 5. So the next Python code is a little bit, looking around and then, putting this out, filtering it out, and looking at this, from a kind of certain percentage perspective. This is a little bit loaded. Think about unbalanced class problems. There's much more pass and fail. So it might be maybe a bias to learn the passes more than the fails, for example. And now, so how to get rid of these classes? You essentially could either say that a pass with condition is a pass. So you kind of say, okay, let's have more of those, put them together, but the fail is a strict fail. And everything else you render here now with this nice function as a -1. And then there's this aspects here where we filter it out, where label is bigger than or equals 0. With this you have, let's say, several of the rest of the data filtered out, and we really have kind of a 2-class problems where we kind of have the pass with conditions and the pass together merged. And this is a little bit common practice. Of course, this could already be a bias in the wording of the violations and so on, perhaps. But again, it's a very simple classifier, so it doesn't matter so much here in this lecture. Now again, just modeling starts with this and thinking about more about these features. And now you have the modeling, you have a 0 and 1 class, pass or fail. And now we look a little bit more on the violations. Now, as I told you, with a linear classification model or also logistic regression, we're a little bit in trouble that it's text. So text multiplied by weight is what? So it's hard to learn from this in a mathematical sense. That's why we have to think about also here how we now get from the, let's say, text representations of the violations to some interesting, let's say, setup where you have a typical way how natural language processing usually works. You take a kind of tokenizer, you put the whole text into different pieces and essentially have a word vector that is just counting essentially the occurrence of words and a certain value and index value that shows you the frequency of that word. So basically how often it is actually there. Negative words here, of course, means then there will be lots of them, perhaps when the violation is really so hard that there will be a fail. So in this sense, you can already see by multiplying this by weights again and again, you will see that maybe this will be coming of a strong pattern. And you will see here that calling a logistic regression function in the cloud is now here very simple. You just have this logistic regression max iteration 10. A regularization parameter is something which is more deep in machine learning. We don't talk about it here, but this is your model, right? So a couple of Python lines here and in your assignment already have created this logistic regression. Underneath the hood, of course, in this pipeline.fit, the whole pipeline is executed on the Spark cluster. It's scalable. It goes across all the different nodes. It will do the logistic regression, but in a parallel distributed manner. Still, there's, of course, stochastic gradient descent and all the approaches of optimization that you don't really see. It's inside this, and we will talk about this, of course, then in lecture 3, when we are essentially having more substance about Spark itself. And then there are lots of model evaluations. I told you we take out the test set now, which is essentially now the same structure. Everything is the same. It's just different samples. And now we use them with the classifier of doing basically with the test data some predictions and see if it is correct or not. And of course, we could even see in the data, if we want, again, if the wording is very negative, it would be probably a fail. So we really learned from it. And what you see here, all the true positive, false positive, it's just another way how machine learners usually work with this. It's called a confusion matrix that you prepare with this, where you really can see, is your classifier working well? Right? And you see true negative is here this, false negative is 10%, true positive is 13%. So this gives you a little bit of handle on the models, how good they are, and you can also nicely visualize it here. Of course, this is all part of your assignment in the end, so I will not talk about everything. It's also for you to find out in your assignment, and then, of course, try it out with a new interesting data set. But I think now you grasp the idea that doing this in the cloud is very, very simple, very, very straightforward. Now, thinking about this, there are lots of machine learning possibilities in clouds, and we just scratched the surface with MS Azure, but still it gave you a very concrete way how you can actually now port decision trees, can do lots of other interesting things. Recommender systems and Sparks are popular. You can directly use Azure with this, but if you have other cloud services like Google or here the Amazon Web Services, of course, they're not standing still. They have machine learning models as well and ways how to create them, which would be here in this video, the Amazon Sagemaker, completely different from the handling essentially. It's a whole GUI on its own, and you have to find out, and we will do in subsequent lectures. And the same way as Google, also different services. Right, but I think that's all what I wanted to leave on the table here for you for today. Again, I think with this material should be much better equipped for the assignment, and talk to you on next week, essentially, when we talk then more about Apache Spark. Questions for the assignment, please put in the discussion section or send me an email. Okay, that's it. Thank you very much and see you next week.